We're at the north end of the Vanderbilt estate at a location which is called Barred Rock. As the name implies, Barred Rock is a massive exposure of bedrock. It's one of the few locations here on National Park Service land where we can see the bedrock that lies beneath the rest of the geology, the soils and the sediments of this area. It's a keyhole through time to a distant moment in time, hundreds of millions of years ago, when this was a very different location. We're at the edge of the Hudson River where this exposure is, but this unit of rock takes us into the very distant past. It takes us back 450 million years to a time long before the Hudson River even existed. It's a unit of rock that has a name. It's called the Norman Scale Formation, and it's a very common rock throughout this region. It's one we know a great deal about. It's composed of two types of rock, and my left hand is on this unit, which is a black shale. Before it was a black shale, long ago, 450 million years ago, it was a black mud accumulating at the floor of an ocean. The other unit of rock is this sandstone. This one is about 5 feet thick. It's a much coarser grained material. It must have a very different history, a much different origin. It's time for us to learn about what it was like here about 450 million years ago. The Norman Scale Formation accumulated at the bottom of a very deep ocean. You would have to travel out to something like the Marianas Trench of the Pacific Ocean to find an environment like this today. The Marianas Trench can be 30,000 feet deep. It can be that deep. The Norman Scale Trench might not have been quite that deep, but it's easy to imagine that the rocks that I'm sitting on originated at water depths of 20,000 feet or more. It's an astonishing thing. Well, let's learn more about that ancient seafloor. The black shales speak to us of normal times. The trench, the Norman Scale Trench, was quiet and peaceful, and mud accumulated very gradually through great lengths of time. This foot or so of sedimentary rock might have taken thousands of years to accumulate. And that was simply the way it was almost every day of the year. The sandstone is different. The sandstone is a catastrophic deposit. It's something that was unusual, even catastrophic. The sandstone, we think, and we're pretty darn sure, represents an ancient submarine avalanche, or a submarine landslide, if you prefer. We see events of this sort happening today, and what almost always happens is a great open ocean seafloor is shaken by an earthquake. And great, enormous volumes of sediment, mostly sand, are thrown up into suspension. The water becomes very dirty with sediment. And then gravity begins to pull that sediment down slope, down towards the deepest part of the ocean. First slowly, and then very, very rapidly. I can put my hand on this sandstone and imagine a moment in time when it was a great murky cloud of dirty water rushing down slope at speeds of 30, 40, 50 miles an hour. It was a very violent event. Well, eventually that mass of dirty water reached the bottom of the trench, and it slowed down, and the sand was deposited. That's what happened here. This must have been an enormous submarine avalanche because it brought 5 feet of sand to this location. Well, that's when the normal circumstances took over and the black mud accumulated. Now let's travel through time. A geologist walks upwards through the rocks and travels through time. This is an old submarine avalanche. This, a slightly younger time, is when the norm took over. And look what we have here. Another submarine avalanche. Again, an earthquake struck, the sand tumbled into the great depths. Then we find here another black shale. The norm, in the normal circumstances, took over. Black mud accumulated. And then there was another submarine avalanche, followed by a great thick sequence of shale, normal circumstances, another avalanche, another avalanche, another avalanche, and up at the top of this exposure, a final avalanche exposed at this location. I stand here at the edge of the Hudson River, the beautiful Hudson River, and I turn 360 degrees and I gaze out at today's landscape. And it's pretty, isn't it? You've got to come here. It's just what we expect out of the Hudson Valley. But in my mind's eye, I turn those 360 degrees and it is 450 million years ago. I stand at the bottom of a great marine trench. All around me, the water is completely black. All around me, the water is frighteningly cold, and my feet are sticking into the soft, wet, sticky, oozy muds at the bottom of an ancient marine trench.